Allegro is a graphics library for C and C++. Unlike regular console applications, by using Allegro, we can access and alter individual pixels in our program's window. As a third-party library, Allegro is not a part of Visual Studio. It is, however, free to download. Installation requires copying the contents of 3 folders to your system. Bin needs to be copied to Windows/System32 and Windows/Sys WOW64. Lib needs to be copied to Visual Studio/VC/lib. Include needs to be copied to Visual Studio/VC/include. Alternatively, you can copy these folders anywhere you like and simply provide Visual Studio with a path to their location. Go to Configuration Properties/VC++ Directories. To create a project using Allegro, you have to define the library you are using by following these steps. Create a Win32 project, not a console application. Select Empty Project in the application settings as usual. At the top of your source file, include allegro5/allegro.h. Go to Properties, Linker, Input, and add allegro-5.0.10-monolith-md-debug.lib to additional dependencies. In Linker, System, set the subsystem to Not Set if you want to see the text window in addition to the graphical window. In a new source file, include the following libraries: stdio.h, allegro5/allegro.h, and allegro5/allegro-primitives.h. Beneath that, write allegro_display*, display equals null. Allegro display is a user-defined data type from the Allegro library, and the asterisk tells us that this variable will be a pointer. By initializing the pointer to null, we are saying that it contains no value. This means the pointer is not storing an address. Before we can use Allegro in our program, we need to initialize the library and its components. This is often done at the start of main, because it keeps the code clean and straightforward. That said, the only requirement of the initialization process is that it needs to be performed prior to any Allegro function calls. When performing a library initialization, or any other operation that may fail, it is a good idea to provide error messages to assist in debugging. Additionally, in the case of an error, we want the program to end. So to keep our program organized, let's create a function to contain all the code associated with initializing Allegro. Since this function does not need to return data, let's make it a void. We'll call it init Allegro, and for parameters, we need 2 ints to contain the width and height of the graphic window. Let's use W and H. The first step is to initialize the library itself. This is done by calling al_init. We want an error message to be displayed if al_init fails to initialize properly. How do we do this? Well, we're making a decision, so let's start with an if statement. al_init returns data, in this case, whether or not the initialization was successful. al_init will return a bool, so the possible response will either be true or false. We want to check if the response is false, but you can't do this directly in C. So we can't check to see if al_init returns false, but we can check to see if al_init returns not true. Basically, computers think positively. Failure isn't in their vocabulary, so you can only refer to it as a lack of success. To do this, let's use the not operator, the exclamation mark. With the condition and function call written, let's write a descriptive error message. Since there is only one line of code after the if statement, we don't need any curly braces. Next, we need to create the display window. To do that, we can use al_create_display. We need to pass the width and height of the window into that function, so pass the parameters W and H. In addition to creating the window our program will use, this function returns some data we need to store. This is where we use the structure we declared earlier, display. After that, let's add a check to see if it worked. Write if not display to check if the variable still has a value of null. If it does, we need to print a message and exit the program. Write printf failed to create display, then exit 0. Exit is similar to return, except that return ends the current function, whereas exit ends the program. If the display did initialize, we can print a confirmation message. We should also clear the new window. This is done by writing al_clear_to_color al_map_RGB 000. Let's break this down. Al clear to color is a function that sets every pixel in the display to a given color. The color is taken as a parameter. Al map RGB is another function that takes 3 integers for red, green, and blue color channels and outputs the color in a structure format that Allegro uses, called Allegro color. Now let's move on to input. Using the same method of putting a function call in an if statement, let's write if not al_install_keyboard followed by printf failed to install keyboard, then exit 0. This sets up the program to accept specific key presses from the user. Finally, let's initialize the primitives add-on. This is why we needed the second Allegro header file. Primitives is used to draw simple shapes. Write if not al_init_primitives_add-on, then printf failed to initialize primitives, then exit 0. Excellent! With that, we've finished initializing Allegro. Next, we need to write a few very simple functions to perform some tasks that require long or awkward lines of code. First, we need another void function to end and clean up Allegro and its components. This function is much smaller than the last one. Call it end Allegro. There's going to be only one line in this function, and that's al_destroy_display display. This line gets its own function because it's rather long, but also because it isn't terribly descriptive. End Allegro is far more clear about what it actually does than al_destroy_display. Next, we need to draw pixels on the screen. Let's write void putPixel int x, int y, int r, int g, int b, and put al_put_pixel x, y, al map RGB RGB as the body of the function. X and y are the window coordinates where the pixel will be drawn. Al map RGB, as we've seen before, is a function that turns RGB values into an Allegro color value. This function exists because we don't want to have to keep writing al map RGB. It's just irrelevant fluff. Another useful function would be one which draws a line. Let's write void drawLine int x1 int y1 int x2 int y2 int r int g int b, then al_draw_line x1 y1 x2 y2 al map RGB RGB 1. This takes a pair of coordinates and draws a line of the specified color between them. Remember how we initialized the keyboard for input? Let's create a function to wait for a specific key to be pressed. Write void waitForKey int k. Then write Allegro_keyboard_state key_state. Allegro keyboard state is another user-defined type. This one contains all the information about which keys are currently pressed. We need a loop to run until the user presses the correct key. Since we don't know how many times the loop needs to run, let's make it a while loop. Let's create a boolean called quit that will serve as our condition. Initialize quit to false, then put not quit in the loop's condition. In the body of the loop, we need to update the keyboard state. Write al_get_keyboard_state &key state. Then we check what the state of the relevant key is. Let's write if al_key_down &key state k, followed by quit equals true. K, this function's parameter, is an integer and represents the ASCII code of the key. Al key down takes the current state of the keyboard, finds the button corresponding to K, and returns true if it is held down. If this is the case, Quit will be set to true and the loop will end. Alright, I'm sure you're tired of putting the fun in function, so let's start writing an actual program and see what all this work can let us do. Here's how this will work. We'll start by initializing Allegro. Then we'll do some drawing. Next, the drawing will be sent to the screen. Finally, we'll wait for the escape key. When that happens, Allegro will get cleaned up and the program will end. The reason drawing things on the screen is a two-step process is because all the drawing data gets put into a buffer, not onto the screen itself. This is due to the fact that accessing the graphics card takes time. As a result of this delay, most graphics programs construct a full frame in system memory and then transfer the frame from buffer to screen. Thanks to our functions, the actual code in main will be relatively light. Let's start by declaring two ints, SW and SH, which will hold the screen width and height. Initialize them to 640 and 480. Then call init Allegro and pass SW and SH into it. Now let's draw some stuff to the screen. Write put pixel 100, 100, 255, 0, 0. This will draw a red dot in the top left corner of the window. We can draw lots of pixels together by writing a for loop. Write for int j equals 150, j less than 200, j++. Then put pixel 150, j 0, 255, 0. This will draw a green horizontal line below the dot. Let's use the drawLine function to make some crazy nonconformist diagonal line. Put in any pair of coordinates you like, as well as a color. Go wild. Then we have to send the screen the data that's in the buffer. The function to do this is al_flip_display. After that, we'll use wait for key, Allegro_key_escape to pause and then exit the program. Finally, we'll call end Allegro to clean everything up. And that's it. Run the program and see what happens. It might not seem like much to write home about, but don't worry. We'll be doing more exciting things with Allegro by the end of this module. And that's it for this part of Module 2 and your first introduction to Allegro.